All right, so in this video, we're going to talk about lesson 8, transfer of energy. And if you remember from class, this was the one that was split up between 2 days. Day 1, we took two different temperatures of water. We had 2 cups, 2 different samples of water at different temperatures. We mixed them. And the point was that we figured out how much energy it takes to move 1 gram of water up 1 degree Celsius. And then that second day was when we had a cup of water, and the other cup had ice in it. And then we figured out how much energy it takes for ice to melt. So hopefully, if you weren't here or you were gone or you just don't have this done, we can take a look and make sure that we are on the same page. So here's the worksheet. For the first day, the lab, you needed to pick your independent variable, your dependent variable, and what the investigative question is. I think in first period we went over this, but for this activity, I'm just going to have you skip that part and go down and read the procedure. So, if you want to do this lab at home, awesome. If not, I just want you to understand what we did. We did that lab, we took our data, we figured out what we figured out. Second day, we did the mixing a liquid with a solid. We followed through those procedures. Again, if you did the lab at home or want to do it at home, awesome. If you just didn't, if you were sick or gone or whatever, just talk to me. But if if you were there and you just didn't get it done, it's not much I can do. So what I really want to focus here on, because really the lab was the activity, but the last part of what we did was define these two terms, specific heat and latent heat diffusion. So specific heat is how much energy it takes to move 1 gram of something up 1 degree Celsius. So in the lab, we figured out for water, it was 1 calorie. It takes 1 calorie worth of energy to move 1 gram of water up or down 1 degree Celsius. One thing we talked about in class was this word calories. And remember, there's little c calories and there's big C calories. Big C calories are what you're used to seeing on food labels. Little C calories, there's 1,000 little C calories in one big C calories. So little C calories are, 1 little calorie is 1,000th of like a food calorie, essentially. But you can see here on the table, there's different substances and their specific heat values. We wrote down this equation right here in class. The energy transferred in calories is equal to the specific heat times the mass in grams of whatever your sample is times the temperature change of that sample. Hopefully, I don't think we'll necessarily need to do it anytime soon, but hopefully you'll be able to know how to rearrange this equation algebraically if you were given, let's say energy transferred, mass, and temperature. How would you use that to solve the specific heat? Basically, how could you rearrange that equation? The other term we learned was the latent heat of fusion, and basically that's how much energy it takes to melt 1 gram of a substance. And here we can see that water, it takes 80 calories to melt 1 gram of water. Gold, from solid gold to liquid gold, it takes 15 calories to melt 1 gram of gold. Aluminum, 95, copper, 49, and so on. So anyway, we also wrote down this equation in our notebooks, the amount of melt, mass in grams, so how much water is melting, or how much of the solid is melting, is equal to the energy transferred into the system divided by the latent heat of fusion. So more than likely, you'll be given 2 of these variables in a question, and you got to solve for the third one. What I really had you do then was just define both of those terms, which we've already talked about. Specific heat is how much energy it takes to move 1 gram of something up 1 degree Celsius. And the latent heat of fusion is how much energy it takes to melt 1 gram of a substance. So those were really the big parts. If you really, like I said, if you really are trying to make these points back up from missing the lab or not doing it, just come and talk to me. We'll figure it out. Worst case scenario, we can have you stay after school sometime or at lunch and make up the lab. So, yeah, if you have any questions, email me, let me know, and we can work on it together. And good job.